addition to the absorption affinity series, there are two other things that will determine the concentration of a particular cation on the exchange sites in the soil. One of those is going to be the concentration of that cation in solution in comparison to all other cations in the soil solution. In other words, it goes back to that equilibrium reaction that I talked about earlier. Anything which increases or decreases the concentration of a cation in the soil solution will affect its concentration or the amount of sites that will occupy on the cation exchange sites. So we've got absorption affinity, we've got the concentration of one cation type to another, and finally the third factor is going to be the concentration of certain anions which occur in the soil. You might be saying, now wait a minute, why would the concentration of an anion affect cation exchange since anions don't go on to these cation exchange sites in the soil? And that's true. That would be a good question. And hopefully I'm going to be able to answer that for you. We need to understand that anions and cations, even though they're in the solution, also can combine back together to form a compound once again. In other words, if we have a high concentration of a certain type of anion occurring in that soil, it can actively be taking cations out of solution and reforming solid compounds again. This process is called a precipitation reaction. Precipitate is a term which comes from chemistry. It's when two things which are in solution recombine to form a solid. That is called a precipitate. An example of how this would work. Aluminum, which has a charge of +3, is very high in the absorption affinity series. But it is not going to occur in appreciable content on exchange sites unless it's also found in soil solution. Aluminum as a cation in the soil solution has a very high tendency to want to combine with hydroxide, OH charged, or OH with a negative charge, hydroxide anions, to form these insoluble compounds or precipitates. So if we have a soil which has very much free hydroxide in solution, then the aluminum cation, even though some of it will be broken out of mineral structures and be a free cation in soil solution, has a very high tendency to recombine with hydroxide and form an insoluble compound called aluminum hydroxide. When that occurs, it takes aluminum out of solution, which means that the aluminum now cannot compete for or be found as a part of those exchangeable cations on the surface of those clay mineral particles. So even though aluminum is found in very high content in the soil and it has a very high absorption affinity, we do not very often see aluminum entering into or becoming a major cation on the exchange sites due to its very strong precipitation reaction with hydroxyl ions in the soil solution.